So today what we're going to do is we're going to talk about vehicle finance, and we're going to focus on fuel costs and fuel economy. So we'll see what's the difference between those two. So when you own a car, and some of you probably have a car already, right? I know I talked to some of you, and so you drove here, so you've had experience owning a car or have a car right now. One of the largest related expenses is fuel. Fuel is the gasoline or diesel needed to go anywhere. The cost of fuel is rising and is not expected to drop. This lesson will examine the cost of fuel and related topics. So, example 1. You are on a road trip. You are having fun, but your car is almost out of gas. You pull into a station and that has a sign. Okay, so we're not really advertising Petro-Canada. What we just wanted to show you is this price, right? So what does this mean? 117.9. The price of fuel. This actually means 117.9 cents per liter. Okay, what does that mean per? What operation is the word per? Per means divide. Yeah. The word of is multiply, per means divide. So it's going to cost 117.9 cents. Okay, this is in cents. Hello, come on in. Per liter. Okay, cents. Now, because this is in cents, we're going to change that into dollars. So how many dollars is in 117.9 cents? How can we change cents to dollars? By 100, right? Because a dollar is 100 cents. So 117.9 cents divided by 100 is really $1.179. Okay. Now you're probably thinking, well, that's not really how we write our dollars, right? That's not how we write money. Because when we're talking about money, we're talking about 2 decimal places. But in this case, we're going to keep all the decimals. So here, do not round. Okay, keep all decimals here. Okay, so it's $1 and 179 thousandths of a dollar. Okay, so 1.179. Okay, so when you see this, that's how many cents it is. So your car requires 67 liters of gas to fill its tank. You see that the price of the sign says 117.9. What will it cost to fill your tank? So how much it's gonna cost? So the cost, you need 67 liters. 67 liters times $1.179 cents per liter, per 1 liter. Okay. So how much is that?
I got 78.993. That's unrounded. $79 rounded.
Yeah. So let's do the math there. 1.179. So it's going to be 78 point. Okay.
Yeah, but nowadays they round it.
Yeah. Now I know we don't pay pennies anymore, but we pay our debits with our debit cards or credit cards nowadays. So if we pay with the debit or credit, nothing is rounded. So, well, it's rounded to 2 decimal places.
Yeah.
So what would it be rounded into 2 decimal places? 78.99, right? 78.99. Okay. This is just in one fill. Okay. How big is a liter? How much is a liter? Yeah. Like if I ask you, like, how much, like, what would it look like? What does it look like for 1 liter? Okay. I think we all buy 2 liters.
In a tank, so.
Okay, yeah, you can't look in the tank, but to visualize what a liter looks like, everybody here, I'm pretty sure, has bought 2-liter pop,
Yes.
right? Yeah, so 2-liter pop. So that one is 2 liters, okay? But this one,
2 liters.
yeah, I was just looking at this one, and I think this is about a liter. So this one is about a liter. So we have to pay $1 something for this much gas or fuel if we fill it up with gas.
But if I seen a sign that says 117.9, I would ask or wonder what the hell is making the price of oil so much.
Yeah, well, yeah, because it's not dollars, it's in cents.
Yeah.
Okay? Actually, today's gas is 98 cents a liter, so I think I might have to fill up my car. Yeah.
Stop buying, get some jerry cans.
Yeah. Okay, that's good. So, good morning. Let's take a look at example number 2. While filling your tank, you take an odometer reading. Okay, stop right there. What is an odometer? The word odometer.
Tells you how long the engine's been running.
Yeah. Odometer reading, that's the one that tells you how many kilometers that's been driven already, right? That's it. At a previous gas station, your odometer reads 21,747 kilometers. So this is when you started. And then now it's 22,453.2 kilometers. Okay, so this is the start, and then the end was 22,000. So how far have you driven? So it's 22,453.2 minus 21,747.3. Okay,
I got 705.9.
yeah, that's sounds correct. So 22,453. That's a 0.2 minus 21,747.3. It's 705.9 kilometers. Okay, so the person has driven. Oh, you need another one. Oh, okay. With your. So since the start to the end, we've driven that many kilometers already, 705. Okay, so far so good. These ones, the ones that we're talking about, are baby steps because we're gonna try to use some of those information to do the other stuff, right? The other calculations. So first of all. So if we know the distance driven in your car and how much fuel liters was used, you can determine vehicle economy. Okay, so now what's a vehicle economy or fuel economy? Fuel economy is defined as the number of liters of gas required to travel 100 kilometers. Okay, so if you want to put a highlight there, a star. Number of liters of gas required to travel 100 kilometer. Okay, so the smaller the number, the less gas it takes to travel 100 kilometer, and therefore better fuel economy. So vehicles with better fuel economy will use less gas and use less money. So the lower fuel economy is actually good. Less is better in this case, right? So we're gonna take a look at how to calculate that right away. So it says here, when choosing a new car to purchase, so this is a brand new car on page 2, the seller should provide you with an estimate of car's fuel economy. The estimate is commonly known as the sticker that lists all the features of the car and the cost of the car. A sample of fuel economy sticker is like this. So if we go shopping for a car, and these are for brand new cars only, okay? It's not for the resale cars. We're gonna have a sticker like this. It kind of talks about a lot of information about the cars. Okay, so what does that say?
Well, it shows you what is the vehicle for fuel, what it can burn in the city and out of the city.
Okay, so let's take a look here. It says here fuel consumption. That means how much fuel is used. They said it's gonna be 9.0 liters per 100 kilometers. Okay, so visualize that. Okay, an average 9 liters per 100 kilometers. So remember what a liter looks like. So that water bottle there that she has, that's 1 liter, right? That's approximately a liter. So if we take 9 of that, okay, I know some people weren't here. Can I borrow this again? So 9 of these, this much gas will help us travel 100 kilometers. Okay, 100 kilometers. That's like about an hour of driving if you're traveling 100 kilometers per hour. So like, okay, leave it like that. Now, this is the average combined, right? But you see that, you see these two numbers right here? It's in the city, it's actually 10.7 liters. We're gonna end up using more gas per 100 kilometers in the city, whereas in the highway it's 7.4. Okay? And you're probably thinking, why is that? Okay. And it says here, this is the annual cost. So, well, this one here could change very quickly, because the cost of the vehicle depends on the price of the gas, right? So we could be looking at about $2,000 a year.
Sorry for the interruption. Could the vehicles parked on the student side who have not registered and not paid for today, please come to the office, KHS 895, Focus Gray, KFD 737, the PT Cruiser, KEA 367 Mazda, HMW 437, Ford Red Truck, KGK 891 Nissan Vehicle. We will be calling the tow truck. Thank you.
Okay. Is that okay? So fuel economy, we'll talk about how to calculate that in a second. So let's take a look. Examine the fuel economy sticker above. Okay, we looked at that one. it lists that the city fuel economy is 10.7 liters per 100 kilometers. So that means we're gonna take 10 liters of gas to travel 100 kilometers. Now, in a highway, it's 7.4 liters per 100 kilometer. State a reason why a vehicle would have a better fuel economy when driving on a highway compared to driving in the city. Anybody
In
have?
the city, you have other vehicles, red lights, everything that could burn more fuel, but on the highway, you're actually helping it. Because you got the cool air coming through the engine.
Oh, okay. Now you're touching two different things there, but I can see where you're, okay. What does it have to do with the number of stoplights in our city and the number of cars?
On the highway, you don't have to stop.
Stop, go. Right. Yeah. Is that what you were gonna say? Yeah. The constant stop and go is actually using more gas in the city, right? Because when you were traveling,
Then you have to start.
You have to speed up.
yes, yeah. And to rev the engine to a certain number of
Speed limit.
to increase the speed of the engine of the car to a certain, like 60 kilometers per hour or 50.
Then it's
From
just
zero,
pumping in more
it
fuel.
uses more gas. So, okay, let's just write it down. It will use more gas. And when I say gas, it could be gasoline, right? Or fuel. Use more gas or fuel to get the car to go after a complete stop. Okay. Okay. Maybe at the lights, the traffic lights, to be exact. Okay. And you know, some people say this all the time, is that if you are at a stoplight, if someone is in a stoplight, and maybe some people already know this, if you're in a stoplight waiting for it to turn green before you go, don't press the gas super hard right away. Okay, do a gradual increase of your speed. Yeah. Don't press too fast on your accelerator, because that's gonna really use up a lot of gas to go from 0 to 60 kilometers per hour. Okay, so do a gradual. Okay, that's a good gas consumption. And also, if you could also already foresee that you're gonna be stopping, okay, because I can see that ahead, a few feet away, that it's gonna turn red, then let go of your foot already of the gas. Okay, and just let the car just kind of cruise on its own. So those are the little things that can make your gas last longer.
Now they got those electric things.
Oh, you know what I really like what the city has done is those countdowns. I like that. Because if I see there's only about 5 seconds left, right? I'm not gonna like press my gas. I know that I eventually will have to slow down and stop. Okay, so I do like the way they had that countdown. You know, like at the walk, like the cross, right? It used to be just like a go
It used to just blink.
pedestrian and then the stop, but then now it's like countdown 20, 19, 18. So that's awesome.
To me, that just means orange or amber, you should have gone faster.
That's
Right? Really
I
should've
think,
gone faster.
I think that's based, well, if you're close enough, yeah, go ahead, right? But if you're kind of far, and you know it's yellow,
Press your left,
huh?
press your left.
Yeah, exactly, yeah.
So,
Never mind those, little kids kind of crossing the street,
Oh, man.
right, with, on their smartphones.
big ones.
Oh, yeah. No, hopefully not, yeah. Okay, so example 4. You are looking at 3 different cars, okay? So they have the fuel economy rates below. Which car has the best? Best. Car A, 8.3 liter per 100 kilometers, 9.2 or 7.8? Which one's the best car in terms of fuel economy?
Now, if you're gonna travel in the city alone, C.
Okay, I would say C, right?
But on the highways, B.
Yeah, we'll just go with the lower. Yeah.
Use probably a little 4-cylinder.
Yeah, it would probably be a 4-cylinder instead of 6-cylinder, right? Now, some people I can see her knows a lot about the car, so that's good. That's good stuff. Okay. That's, like I said, in this particular lesson or this particular unit, vehicle finance, I'm pretty sure some people already have a lot of experience with cars and owning cars, so it's not gonna be brand new. So if you know the fuel economy of a car, you can predict how much gas it will use in liters to drive a certain distance. It is important to remember that this is just a prediction, okay? This is a prediction. The actual fuel economy will vary according to the driving conditions and how the driver decides to drive the car. Using the fuel economy, you are looking to purchase a used car. You found this car, Honda Civic, but before you buy it, you want to check the fuel economy. You look online, okay? And it says here it's 6.7 liters per 100 kilometers. So a liter, okay, about 7 liters. 7 liters of gas to travel 100 kilometers. Okay. So you drive an average 2,100 kilometers every month. Use the fuel economy to determine the approximate number of liters of fuel you will need to purchase each month. So we need to figure out the amount of fuel that you will need. So how do you do that?
You would times the 2,100 with the 6.7.
Yeah. So 6.7 liters per 100 kilometers. I think if we write it this way, okay, if we write it this way with liters per 6.7 liters per 100 kilometer times how many kilometers? 2,100 kilometers. Okay, I'm thinking you did this too. If you've taken some science class, you do a lot of these rate stuff. Can you see that liters per kilometer and then timesing it by timesing it by kilometers? Kilometers, the numerator will cancel the denominator, right? Kilometers per kilometers cancels. What's left over? You're left with just liters, okay? Now, if you've taken some science courses, you've probably done something like this, where it's called a unit analysis. How do we do that? What's the math for that? So 6.7 per 100 kilometers. So per means divide. Okay, so let's do that. So 6.7 divide by 1,000, not 1,000, 100 times 2,100. So it's gonna amount of fuel, it's gonna be 140.7 liters. Okay, because this is amount of fuel, not amount of money. Okay, so if the average cost of the fuel is $1.15 per liter, $1.15 per liter, calculate the cost, the expense, the cost of that. So how much would it cost to use up 140.7 liters? So cost is equal to 140.7 liters, timesing it by $1.15. What does the word per mean? Divide, per liter. Okay, per liter, per 1 liter. What unit cancels in this case? Liters, right? The liters in the numerator will cancel the liters in the denominator. So we're left with times 1.15. Oh, this is what I'm gonna get. Because we're talking about cost, we're talking about money, this is gonna be equal to 161.81 cents. I would have to round it up to 81 because it's 5 or higher is rounded up. Okay? I'll refer. Okay. So that's okay. I'm just going to take a quick look over here. Not bad. Okay. I think what we'll do is we'll finish up example 6 and then I'll assign some questions so that we have time to just work on that our assignment here. So you keep a careful records of how much fuel your minivan uses. Okay, well, good for this person. And have determined that the fuel economy of the highway is 11.2. So in the highway it's 11.2 liters per 100 kilometers. You are on a trip through rural Manitoba. You pulled into the gas station at 1 a.m. Whoa. When your tank was completely empty and it took 71 liters of gas. Determine if you will make it to the next gas station if the next gas station is 550 kilometers away. Okay. So here's so much information. So you're going, so this is where you are now, and then this is where you're going. This is the gas station here now, and then this is the next gas station, which is 550 kilometers away. Okay. Your tank is almost empty and it took 71 liters of gas to fill up the tank. Determine if you will make it to the next stop, which is 550 kilometers away. Okay, let's see if we can make sense of this. So if it's 550 kilometers away, okay, how many liters of fuel will it take to go from here to there? That's what we're trying to figure out, right? So,
Well, first you
What can-
divide the 11.2 with the 100.
mm-hmm.
That'll give you how much your vehicle will run.
And times it by 5.
Yeah.
Mm-hmm. Okay. So we could go here, amount of fuel. Okay. It's gonna be 11.2 liters per 100 kilometer. Times, how many kilometers do they need to run? 550 kilometers. Okay. What units cancel in here? Kilometers, yeah, kilometers would cancel. Okay, kilometers would cancel. So how many kilometers is that? Oh, yeah, how many liters is that? 61.6 liters, right? It has to be liters because it's what's left. Okay. You're not gonna make it, right? Because your next, it will take 71. We need 71 liters. So this is, which is less than 71 liters. So that means the next one that's open is too far for that person to travel.
Well, at least at 1 o'clock in the morning, he's gonna be able to push.
You push, I'll do it.
Who wants to push their car? Okay, so yeah, there is not enough fuel to get to the next station. Right. Yeah. Now, and then you look at this, like, when I was reading this question, it's like, what's the point of putting it at 1 a.m.?
Yeah, putting the time
Right.
in, like,
Putting the time in kind of gives us a scenario that, hey, this is late at night, not a lot of gas
early in the
station.
morning, and which gas station is actually open at 1 o'clock in the morning?
Yeah.
Unless somebody has a jerry can.
Well, unless they have a can in the back, right, for the extra fuel.
Depending on how long the vehicle.
And again, that's not part of the scenario. Right? Okay, that's good.
What does it say there behind your head, not what?
Oh, there. Yeah, there is not enough fuel to get to the next station. So I would say stay where you are and then wait till the next day, and then probably more gas station will open up. Okay, I'm gonna stop right here. What we'll do is we're gonna, split this lesson in half. Well, kind of half. But now this one will give us some time to actually do some work. So I'll give you some questions for you to try now, okay? So you don't have to do as much. Okay, yeah, can you do number 1? State 2 reasons why you should pay attention to fuel economy of your vehicle. Yeah, you could. The chart, looking at the chart. Oh, looking at the chart here. The gas prices is going up and up, down, up. Did we? Yeah, we did. Yeah, I said we're gonna leave that, cut it in half. Yeah, so these ones are the ones that you can work on now. Okay, 1 and 2. Number 3 for sure. Number 4. Number 5. Number 6. Number 7 and number 8. Okay, so your assignment now is for you to work on questions 1 through 8. Okay? Tomorrow we will finish up the lesson and then we should be able to do the rest tomorrow. Is that good?